Coder, a new language presented by Andrew Kapuros. Here's our social contract, basically laying out all the rules. As you can see, it says if you do not do your work, it is minus 5 points off your grade. Here you have the email contacts to each members. Here we have the defined problem, basically saying we will be using computer systems, and we are instructed to use to create a process encoder decoder, which will involve 26 letters or characters that are fictional, and basically encode and decode those. This is our brainstorming. Basically, we use computing devices that we had, and we discussed languages that we found off the internet, and basically came together and picked out the ones we most liked, and then picked one that we would create. And so here are the goals. You can read them out. The requirements, like I said earlier, has to be 26 letters or characters, has to be fictional or one that you created your own. It has to be in riddle form that the user will answer, and it cannot be binary, meaning that it cannot be A equals the letter K. It cannot be something like that. Here are the ideas that we came up with, and the one that we ended up picking you will find out shortly. Here's our decision matrix, basically laying out the criteria that we had and how we graded each design off of those. So the one we ended up choosing was the Chekhovsa from the fictional movie Dune. And the reason we picked this one is basically because it already had an existing alphabet, which made it easy to import each letter into the code. And that just made the process of making this much shorter, and it caused less hassle. Here's the starting code given by PLTW, and the reason this was helpful to us was because we looked at line 56 to 78, and we basically said, this is already giving us a blueprint of how to say A equals this symbol or whatever it was. And that gave us an idea of how to make our code more efficient and how to make the whole process more efficient. Here's our Gantt chart. You can see who did what and what was created on what day, and how work was distributed is basically we said who has the best skills in each topic. Say my skill might be coding, and we basically gave that person more coding parts, or maybe it was they helped more out on the making the presentation look nice, whatever. We did still allow everyone to get a piece of each part of the design, so everyone still had to create some sort of code. Everyone still had to contribute to the presentation somehow. But yeah, here's the flowchart. Here's the pseudocode, which will be explained more in the actual code, but basically what it's saying is you're going to have an image popping up with a text box saying what's the answer to the riddle. You have to type in your answer, and then it shoots out, is this correct, yes or no? And yeah. Here's the code in progress. As you can see, here's the whole alphabet plus a couple other characters that are put in as images. You have your question, and you have your answer box. Like I said earlier, image of the question, answer box, type it in, and it shoots out, is this correct, yes or no? And so what was missing from the code is when the answer is inputted, we needed to have it encrypt that answer into the language again, but we did not have time to create this part of the code. It was a little bit more difficult for us to figure out. So in time-saking manner, we just left it out and presented what we had. So what could be improved? Personally, I think that we could have taken paired programming, so we could have taken a person without Visual Studios and someone with Visual Studios, paired them together, and had them code with each other. Because the main problem was that we did not have Visual Studios, and Visual Studios is what allowed us to use images. And since not everyone had that, it was hard for us to completely fulfill our code. Here's the debug chart. You have your letter image, which is supposed to obviously pop up an image of, sorry, no. Letters to images. This is basically saying A equals this image, B equals this image, and it did just that. Obviously, those images were symbols that we got from the language. The only problem was not everyone had VS, so not everyone could see these images, or not everyone could run the code because the images would not pop up for them. Riddles for questions. The riddle should pop up an image of whatever riddle we picked. I think for ours was why our apple was red or green, whichever it was. It did exactly that. No fixes needed. Display. It displayed a text box that allows you to answer the question. Did exactly that. No fixes needed. Riddle answer, like I said earlier, when the answer is put in, it should have popped up the deciphered version of that. So it should pop up the new language that we picked, which it did not do, like I said earlier. Run, it should just loop the code so that way when it reaches the last line, it doesn't just stop. And it did exactly that. No fixes needed. Here's my evaluations and people that I evaluated. Here's the response to the evaluations. After looking at the key points, as a group, we basically just looked back and decided how we could better document the process that we took to make this encoder/decoder. And thank you for watching. QR is not there, obviously, because I'm recording it right now.